Greetings to the respected faculty. I am Lasya Mandapati from CSC AI&ML B section. My roll number is 24951A6686. And today I'll be presenting on the topic Network Image Enhancement with AI in Chronic Disease Management. This topic explores how medical imaging combined with artificial intelligence is reshaping the way we detect, diagnose, and manage long term health conditions. So, let's discuss this in further detail. Let's begin by understanding chronic diseases. Chronic diseases are health conditions that last for a long period of time, often lifelong. These diseases cannot be cured completely, but they can be controlled. For example, diabetes, hypertension, cardiovascular diseases, and even chronic respiratory diseases, and even also cancer is also an example. Now, why are these so important? Because they are the leading cause of death and disability worldwide. The biggest challenge is not just treatment, but early detection, accurate diagnosis, and continuous monitoring. That's exactly where advanced imaging and AI come into play. Medical imaging is at the heart of disease management. It allows doctors to look inside the human body without any surgery. Some common imaging techniques are MRIs, CT scans, X rays, and ultrasounds. These tools help in detecting tumors, monitoring disease progression, and planning treatments. However, there are still challenges. CTs and X rays expose patients to radiations. Also, many images suffer from noise or artifacts that reduce clarity. Image Imagine trying to detect a small tumor in a blurry image. That is a big risk. So, we need technologies that can improve image quality drastically. Now, it's no shock that artificial intelligence or AI is transforming Healthcare. It uses algorithms, especially machine learning, to mimic human intelligence. Applications are vast. For example, predictive analytics to forecast diseases, personalized medicine to tailor treatments, and even robotic surgeries. The benefits are clear though. AI can enhance accuracy, reduce human error, and speed up the diagnosis process. However, the challenges still remain. Data privacy is a huge concern, and many algorithms work like black boxes, meaning doctors can't always see how these decisions are made by the AI model. Plus, integrating AI into busy workspaces like hospitals is not always a smooth and easy task. Now, when we talk about network image enhancement, we're talking about using AI to improve the quality of medical images. There are three main techniques to achieve this. First is noise reduction, where we remove unwanted graininess of the image. Next is resolution enhancement. Here we sharpen images to see tiny details. And lastly, it's artifact removal, where we eliminate distortions caused by equipment or even by patient movement. To do this, AI models like CNNs, GANs, and autoencoders are used. Each one plays a different role in improving images. This is like upgrading an old blurry camera to a modern high definition one. This flow shows the steps in AI-based medical image enhancement. First, images are captured through scans. Then, pre-processing cleans them up. Enhancement uses AI to sharpen details, reduce noise, and even remove artifacts. Post-processing fine-tunes the results. And finally, analysis provides doctors with clear, reliable images for the diagnosis. Now, let us look deeper into these models. So, CNNs or convolution neural networks are excellent at learning features automatically. They're widely used for tasks like detecting tumors. GANs or generative adversarial networks take a low quality image and generate a clearer, high quality version. They're great for enhancing low dose CT scans. Autoencoders, on the other hand, compress the image, then reconstruct it while filtering out noise. So this makes it perfect for improving MRI scans. These models will be able to help radiologists see more clearly, which makes fewer missed diagnoses. Here are the three deep learning models used in medical image enhancement. CNNs automatically detect features, which is useful for tumor detection. GANs generate clearer images from low quality scans, especially in low dose CTs, like we discussed before. And finally, autoencoders compress and reconstruct images to remove noise, improving MRI scans. Together, these three features make medical images sharper and far more accurate. This is where things get exciting. AI is already being used for chronic disease diagnosis. For cancer detection, deep learning models can identify lung cancer from CT scans, sometimes more accurately than even humans. For cardiovascular diseases, AI can predict a person's 10-year heart disease risk using just a chest x ray. And in neurology, AI can detect Alzheimer's disease early using multimodality imaging. These applications show how AI enhanced imaging supports doctors in catching diseases earlier and with more confidence. This diagram shows how AI supports diagnosis. Medical images are analyzed by an AI model, and the radiologist decides whether to accept or reject the result. Accepted results go into the report, while rejected ones provide feedback to improve the AI. This way, AI learns continuously while the doctors stay in control of the final diagnosis. AI is not limited to hospitals though. With remote monitoring, patients can be tracked at home using wearable devices and mobile apps. These devices collect data like heart rate, blood pressure, and glucose levels, and they send it to the cloud systems where AI analyzes it. The benefit: early detection of problems, reduced visits, and personalized care. The challenges continue to exist. Data security must be ensured, devices must be reliable, and patients need to use them consistently. Still, it's a big step towards preventative healthcare. Here's a real world case study. A model called the DUNet was developed for stroke lesion segmentation. Stroke lesions in the brain are often hard to detect accurately. However, the DUNet combines 2D and 3D convolution networks to identify lesions more precisely. The result was faster and more accurate segmentation compared to older methods. This directly helps doctors in treatment planning as accurate imaging is crucial for stroke discovery. This image here shows a less precise, manually or less accurately segmented outline of the stroke lesion, as you can see on the left. The segmentation is broader and may not accurately capture the full shape of the lesion. However, after the DUNet, which is the image on the right, this image shows a more refined, accurate, and precisely delineated outline of the stroke lesion. The DUNet model has improved the segmentation by better identifying the exact boundaries and shape of the lesion. AI is also helping personalize treatment. Instead of a one-size-fits-all approach, AI combines data from imaging, genetics, and lifestyle to create a customized treatment plan. For example, in cancer, AI can predict whether a patient will respond well to a particular therapy. This saves time, reduces side effects, and increases treatment success rates. Personalized medicine is the future, and AI is a key to making it work. Of course, there are barriers. Data privacy is a major issue. Patient records are sensitive. Then there's model transparency. Doctors want to know why an AI system gave a certain result. Regulatory approval so slows things down, since healthcare rules are strict. Finally, healthcare providers need training to use these tools efficiently. Addressing these challenges is essential if AI is to become a trusted part of the healthcare system. The future, however, looks bright. We're moving towards more accurate AI models, deeper integration with electronic health records, and even global access to AI tools in low resource settings. Imagine rural hospitals being able to use AI tools on a smartphone to detect health scares like heart diseases or cancers. That's the level of accessibility we're aiming for. The future is about precision medicine and equal access to all. Whenever technology is involved in healthcare, ethics matter. We must ensure AI is fair and unbiased. Patients must give informed consent before their data is used. If the AI makes an error, accountability must be clear. Who takes responsibility? And finally, we must balance AI recommendations with patient autonomy because at the end of the day, AI should support, not replace human decision making. To conclude, AI in medical imaging is transforming chronic disease management. It leads to earlier detection, better diagnosis, and more personalized treatments. The impact, however, is huge. Improved patient outcomes, reduced costs, and better healthcare access. The future lies in continued research, collaboration, and responsible adoption. So, my final message is AI is not replacing doctors, it's empowering them to provide better care. Thank you for listening to my TED Talk. I hope today's talk inspires us to see AI not as a replacement, but as a partner in creating better outcomes for patients everywhere.